Hi everybody, welcome back to Beginning Algebra. Today we're in section 2.7, so we're going to be solving linear inequalities. And today our objectives are to learn how to graph intervals on a number line, not a coordinate system, but just a number line. And we want to practice using the addition property of inequality and the multiplication property of inequality. Both of these are very similar to the addition property of equality and the multiplication property of equality that we use to solve equations. There are just a couple of important differences we want to talk about. And so after we look at both of these properties, we'll practice solving some linear inequalities together. Okay, first, the difference between an equation and an inequality is that an equation has an equal mark, where an inequality will relate to algebraic expressions using one of these symbols. This one that points to the left is the less than symbol. This one that points to the left and has a line under it is a less than or equal to. And of course that line is like the bottom line of an equal mark, so less than or equal to. This one that points to the right is a greater than, and this one that points to the right and has a line under it is a greater than or equal to. Now the way to tell these apart is to remember that you read them from left to right. So if you come to the smaller end of the symbol as you're going from left to right, if you come to the smaller end first, you're going to say less than. If you come to the larger end first, you're going to say greater than. So we're always reading from left to right. This would be a less than, and this would be a greater than. Okay, so a linear inequality in one variable, and here we're using x for our variable, can be written in any one of these forms. You'll have an x term and a constant. So here the a and the b and the c represent real numbers. The a number would not be allowed to be 0 because if a were 0, then your x term would disappear. So b can be 0 and c can be 0, but otherwise these are just regular numbers. And so you can have an x term and a constant less than a constant, or an x term and a constant less than or equal to another constant, and so on. So basically the thing that makes these linear inequalities is that we have an x term and we don't have an x squared or an x in the denominator or anything weird like that. So here are a few examples of linear inequalities. We could have x plus 5 is less than 2. So here the a number is 1, the b number is 5, and the c number is 2. We could have z minus 3/4 is greater than or equal to 5. So in this case, the a number would be 1, the b number would be minus 3/4, and the c number would be 5. Or we could have 2k plus 5 is less than or equal to 10. And all three of these are linear inequalities. Now, one thing that's different when we're solving inequalities than what we saw when we solved equations is that the solution to an inequality will not be just a single number. The solution to an inequality is usually a range of numbers. Like your solution will be all numbers that are less than 7, or it might be all numbers that are greater than -2. And so it's often helpful to graph the solution of an inequality on a number line. At the end point of the graph, we'll either use a bracket to show that a number is included in the solution, or we'll use a parenthesis to show that the number is not included in the solution. Now, a lot of students remember this from high school algebra, and you might remember that in high school, you probably used an open circle to show that the number was not included, and you used a closed dot to show that the number is included. Well, here we're using bracket to show that it is included and parentheses to show that it's not. And there's a reason for that switch, and I think you're actually going to end up liking it better. But for right now, it may be a little different from what you're used to. So now, in example 1, we're going to start out by just graphing each of these inequalities on the number line. So you don't have to draw a very fancy number line. The only number that I ever label on my number line is the number that I'm worried about from my inequality. So I want to graph here all the numbers that are less than 2. So I'm just going to put one number on my number line, and that is the 2. And now we want to shade the numbers that are less than 2. So the numbers that are less than 2 on the number line would lie to the left of 2. So you want to draw an arrow to the left of 2, and you do need to draw an arrow to show that the shading should continue forever in this direction. And now the question you have to ask yourself is, should this 2 be included in the shading or should it not? Well, if you think about what this inequality says, it actually says that we only want to shade the numbers that are less than 2. 2 itself is not less than 2, so we would not want to include the 2 in our solution, and so we'll put a parenthesis right there to show that the 2 is not included. Now let's graph x is greater than 2. So again, we will label our number line with a 2. The numbers that fit the description of being greater than 2 are to the right of 2. And again, we do not want to include 2 in our solution because we only want to shade the numbers that are greater than 2. So we'll put a parenthesis right here. Okay, now for part C, we have x is greater than or equal to 2. So again, we'll label our number line with a 2. And again, we will shade the numbers that are greater than 2, so we'll shade the numbers to the right of 2. But this time we do want to include the 2 as part of our solution. So instead of a parenthesis, we'll put a bracket here. And the square bracket shows that the 2 is included in the solution. And then for x less than or equal to 2, again, we'll put the 2 here. And we'll shade this time the numbers that are less than 2. So we'll shade the numbers to the left of 2. And we'll use a bracket again to show that the 2 is included in the solution. So notice how this works. When we have a less than symbol, we shade to the left of the number. If we have a greater than symbol, we shade to the right of the number. If we have the or equal to bar on our symbol, we use a square bracket. And if we do not have an or equal to bar, we don't use the square bracket, we use the round parenthesis. Now that we know how to graph the solution on a number line, let's talk about interval notation. Interval notation is just a way of describing the interval that is shaded on the number line. Interval notation is always stated from left to right. So you start with the left end and you go to the right end. The left end of the line is represented by negative infinity. And the right end of the line is represented by positive infinity. So you know the infinity symbol is represented by that loop. It looks like an 8 on its side, so it would look something like this. So this would be negative infinity, and then the right end would be positive infinity. So let's take 4 more inequalities, and this time let's not only graph the inequalities, but let's also state the interval notation out here. So our first inequality is x is less than -5. So start by labeling -5 on your number line. The numbers that are less than -5 are to the left of -5, so we'll shade to the left. Because we don't want to include -5, we'll put a parenthesis here. Now the interval notation will be from the left to the right. So we have to ask ourselves, where does the shading start on the left? Well, it seems to go forever to the left. So remember I told you the left end of the line is called negative infinity, and the right end of the line would be called positive infinity. So our shading here is going from negative infinity to -5, and it stops at -5. So the interval notation will be from negative infinity to -5, and then put a parenthesis because we had a parenthesis on our graph. So now we would look at this interval and we could say that the solution includes all the numbers between negative infinity and -5. Again, I want to remind you that it's very important that the interval notation go from left to right. Sometimes people want to start with the end of their graph and go toward the arrow, and you can't do that unless the graph happens to be going the right way. In this case, if you started at the end and went toward the arrow, your interval would not be right. So you have to go left end, right end. Okay, now let's look at part B. X is greater than 1/2. So we'll put a 1/2 on our number line, and we'll shade the numbers that are greater than 1/2, so that will be everything to the right. And I have the parenthesis here to show that the 1/2 is not included. And now remember, the left end of the line is negative infinity and the right end is positive infinity. So this shading goes from 1/2 to positive infinity. So I'll put parentheses 1/2, comma, infinity. Okay, now for part C, we want to graph x is less than or equal to 25. So I'll label my number line with a 25. The numbers that are less than 25 are to the left, and we have an or equal to line. So this time I have a bracket at the end of my shading. And remember, the left end of the line is negative infinity, the right end is positive infinity. And our shading here goes from negative infinity to 25 bracket. Now, this is a question you might have. If the number has a bracket, should I put a bracket with the infinity symbol as well? And the answer is no. So we'll have here parentheses negative infinity to 25 bracket. Now, the reason that the infinity symbol still has parentheses is because infinity is not actually a number that we can include in our solution. Infinity is just an idea. So we can go toward infinity, but we can never reach it. So we can't actually include it. We only can show it with parentheses. So again, this solution is represented by the interval from negative infinity to 25. Remember, left end, right end. And then for part D, we will label our -8 on our number line, and we want to shade all the numbers that are greater than or equal to -8. So greater than is going to be to the right, and we'll have a bracket here because we do want to include -8 in our solution. And now our interval will be from -8 to infinity. So remember, left end, right end. So the shading starts at -8 on the left and it goes to infinity on the right. And also remember that even if your number has a bracket, infinity and negative infinity always must have parentheses. Okay, so again, since infinity is not a real number, it can never have a bracket. Negative and positive infinity always use parentheses. And if the variable in an inequality is on the right, you should always restate that inequality so that the variable is on the left before you try to graph or state the interval notation. It's a source of a lot of confusion that students just look at the symbol and they don't think about where the variable is. But it's very important that the variable is on the left before you try to figure out which end of the number line you need to shade. So here's an example for us. We want to graph the inequality 3 is greater than x. Now if you just look at the greater than, you might be tempted to shade to the right. But notice that this inequality is backwards from the other inequalities that we've dealt with. You have to keep in mind, if 3 is greater than x, that can also be stated the other way. We could say that x is less than 3. You remember what your third grade teacher taught you about the alligator's mouth? Well, if you look at this statement, the alligator's mouth is eating the 3, so the 3 is greater. If you look at the way we restated it, the alligator's mouth is still eating the 3. So this statement says the same thing that our problem said. It's just that now we have restated it in a way so that the variable is on the left. So now we have x is less than 3. We can label our number line with a 3. And the numbers that are less than 3 lie to the left of 3. So we will shade everything to the left. And we'll put the parentheses because we don't want to include the 3 in our solution. And now the interval notation for this graph would be from negative infinity to 3 parentheses. Now let's talk about the addition property of inequality. We can add the same value to both sides of an inequality just the way we did when we solved equations. But keep in mind that when we solve an inequality, we always graph the solution on a number line and we state the interval notation. So the addition property of inequality works exactly the same way as the addition property of equality did. Let's look at this example together. So here we have 7 plus 3x is greater than or equal to 2x minus 5. And notice it says graph the solution set and state the interval notation. So if this were an equation, what would you do first? Well, you probably remember that whenever we have variable term and constant on both the left side and the right side, we always used to start by eliminating the smaller variable term. So I'll start here by subtracting 2x from both sides. That's going to give us 7 plus 1x, see 3x minus 2x is 1x, is greater than or equal to 2x minus 2x, which is 0, minus 5. So we'll just have greater than or equal to negative 5. Okay, now we're trying to isolate the x, so the next thing to do is subtract 7 from both sides, and that's going to give us x is greater than or equal to negative 5 plus negative 7, which is negative 12. Okay, now because this is an inequality, we need to graph the solution on a number line and state the interval notation. So here's my number line, and I've just labeled it with a negative 12, and I have to ask myself, where are the numbers that fit this description? Where are the numbers that are greater than or equal to negative 12? Well, they are to the right of negative 12, so I'll shade everything to the right, and I'll put a bracket so that I'm including negative 12 in my solution. And now remember, interval notation goes left end, right end. So the interval notation goes from negative 12 to positive infinity. So we have bracket negative 12, comma, infinity, parentheses. Now because an inequality has many solutions, it's not possible to check all of them. But if you want to check the solution to an inequality, all you really have to do is check that the endpoint is correct and that the shading is going in the right direction. That does take 2 checks, but if you really need to check your answer, it's worth it. So let's check our solution. X is greater than or equal to negative 12. So first we will test the negative 12. So even though this is an inequality, the negative 12 is the number that makes both sides the same. So we just want to check that negative 12 makes the two sides equal. So plugging negative 12 into our statement, we have 7 plus 3 times negative 12 is supposed to be equal to 2 times negative 12 minus 5. Let's do the multiplication here. 3 times negative 12 would be negative 36, and 2 times negative 12 would be negative 24. And now let's just add both sides up. 7 minus 36 would be negative 29, and negative 24 minus 5 would also be negative 29. So the two sides do match, and that tells us that negative 12 was the right number. But it doesn't tell us whether we had our shading going in the right direction. So to find out whether the shading is going in the right direction, what we need to do is test a number that's in the shaded area. So think about the graph that we had on the last slide. You can pick any number that would be in the shaded area. I like to use 0 whenever it's possible. So in this case, 0 would be in the shaded area. So I'm going to check that the shading is right using x equals 0. So we're just going to plug 0 in here. So we'll have 7 plus 3 times 0 is supposed to be greater than or equal to 2 times 0 minus 5. Of course, 3 times 0 and 2 times 0 are both 0. So we'll get 7 is greater than or equal to negative 5. That is a true statement. So that tells me that my shading is going in the right direction. So if I had gotten a false statement here, I would have known that my shading was supposed to go the other way. This is not something that you have to do on every problem. It would slow us down a lot if we had to do 2 separate checks on each problem. But anytime you've kind of lost your confidence and you're not sure if your answer is right or not, keep in mind that you can do the check this way. Now, the multiplication property of inequality is just a little different from the multiplication property of equality. For the multiplication property of inequality, we can multiply both sides of an inequality by the same positive number, and the inequality will still be true. And we can also divide both sides of an inequality by the same positive number. So far, it's exactly like the multiplication property of equality, but here's the difference. If we multiply or divide both sides of an inequality by a negative number, we must reverse the inequality symbol to keep the inequality true. So let me show you why that is the case. Let's take an inequality that we know is true, that does not have any variables in it, like 10 is greater than 3. That is a statement we can all agree on. If I multiply both sides of this inequality by a positive number, like positive 5, then what I get on the left side is 50, and what I get on the right side is 15. And you see the inequality is still true. 50 really is greater than 15. But if I take the same inequality and multiply by a negative number, then what I get is that negative 50 is greater than negative 15, and this is not true. Negative 50 is actually much smaller than negative 15. So this is false, and that's why if we multiply both sides of an inequality by a negative number, in order to keep this statement true, we have to reverse the inequality symbol, like this. So now, if we change the greater than sign to a less than sign, then the inequality is true again. So we can multiply or divide both sides of an inequality by a positive number, no problem. But if we multiply or divide both sides of an inequality by a negative number, we must reverse the inequality symbol to keep the inequality true. So here's example 4. Let's solve each inequality and graph the solution set and then state the solution in interval notation. So we've got 3x is less than negative 18. So to solve this, I would need to eliminate this coefficient of 3. So I would divide both sides by positive 3. And you see, because I divided both sides by a positive, I will not need to reverse the inequality symbol. So that's going to give us x is less than negative 18 divided by 3, which is negative 6. Okay, let's graph that on a number line. The numbers that are less than negative 6 are to the left. This does not have the or equal to bar, so we have parentheses here. And our interval notation is from negative infinity to negative 6 parentheses. And now let's look at part B. Negative 4t is greater than or equal to 8. So to solve this, I would need to divide both sides by negative 4. So I can do that, but when I do that, I must reverse the inequality symbol. So right here in the same step, I'm going to change that greater than or equal to a less than or equal to. So now I have a statement that says t is less than or equal to 8 divided by negative 4, which is negative 2. Now look, it's important for you to reverse the inequality in the same step where you divide both sides by negative 4. If you wait and do it in the next step, then this step is actually wrong. So both of these things have to happen at the same time. When you divide both sides by a negative, you must reverse the inequality at the same time, or right there in that step, what you're showing is not correct. So now let's graph this solution on a number line. Here is our number line with the negative 2 labeled. Where are the numbers that are less than negative 2? They are to the left, so I'll shade all the numbers to the left of negative 2, and because we have the or equal to bar, I put the bracket on here, and now our interval notation is from negative infinity to negative 2 bracket. And here are a couple more practice problems for us to look at where the coefficients are fractions. I'll do one with you and then you can do this one on your own. So when we look at this one, it says negative 3/8 times x is less than or equal to negative 12. And of course, we would want to eliminate this negative 3/8 coefficient. So remember, the way to eliminate a fractional coefficient is to multiply by the reciprocal, but we have to multiply both sides by that reciprocal. So now, because we're multiplying both sides by a negative number, we'll have to also reverse the inequality symbol. So my less than or equal to sign has now changed to a greater than or equal to. And notice now that my 3's are going to cancel, my 8's are going to cancel, and negative times negative is positive. So the entire left side now just boils down to x. Then we have greater than or equal to. And right here on the right, let's do our simplifying before we do the multiplying. You don't want to have to multiply negative 12 times negative 8 because that would make a large number. So let's simplify first. Negative 12 divided by 3 would be negative 4. This negative 4 times this negative 8 would be positive 32. So our solution is x can be any number that is greater than or equal to 32. And so we want to graph that on a number line. The numbers that are greater than 32 are to the right of 32. And we have a bracket there because of the or equal to bar. And now our interval notation will go from 32 to infinity. Now I hope you'll pause the video and try working this one on your own. So now if you've had a chance to do that, I'm going to go ahead and go through it with you. Let's take this inequality, and we want to eliminate this coefficient of negative 2/5. So we'll multiply both sides by the reciprocal of negative 2/5, and because we're multiplying both sides by a negative, we'll have to reverse our inequality symbol. So it is now a less than sign. On the left, negative 2/5 times negative 5/2, everything cancels out and leaves us with just x on the left side, and then we have less than. Here, 8 divided by 2 will give us 4, and that 4 times this negative 5 will give us negative 20. So our solution is x is less than negative 20. So any number less than negative 20 would make our inequality true. Let's graph those numbers on the number line. The numbers that are less than negative 20 are to the left of negative 20. And then we have the parenthesis here because we do not have an or equal to bar. And our interval notation would be from negative infinity to negative 20 parentheses. Now if you remember our 4-step process that we used to solve equations, we can use that same procedure here on inequalities. So pretty much on every inequality, we want to start by simplifying each side separately. That is, distribute to get rid of any parentheses and combine any like terms that you have before you start trying to solve. Then you want to isolate the variable terms on one side of the inequality, and then finally you can divide to eliminate the coefficient so that you isolate the variable. Of course, our 4th step when we solved equations was to check each solution. It's not as practical here to check every single time because that requires 2 steps, so I won't make you do that, but I do think it's a good idea for you to check a few of them as you go through your homework. Try and check them and make sure that you are comfortable with the checking process, because when you're taking a test you might want to check your work, and it's a good idea to know how in case you decide that you need to do that. When you're solving inequalities, the only differences you have to remember are that if you multiply or divide both sides by a negative number, you must reverse the inequality symbol. And also, for inequalities, we always graph the solution on a number line, and we state the solution in interval notation. So that is something we did not have to do when we solved equations, because the solution to a linear equation is just one number. But with inequalities, the solution is a range of numbers. So we always take these couple of extra steps just to make sure that the answer is especially clear. Now let's take this inequality and apply all of our solving skills to it and see what we come up with. So here we have 3x plus 2 minus 5 is greater than negative x plus 7 plus 2x. So the first step is to simplify each side. So before you start trying to do the same thing to both sides, look at the left side and see if there are any terms to combine. Of course, 2 minus 5 would make negative 3. So the left side is going to be 3x minus 3. Then we have our greater than symbol. And when you look at the right side, the negative 1x and the positive 2x add up to positive 1x. So that's going to give us x plus 7. Now we are ready to start solving. So notice that we have variable and constant on the left, and we also have variable and constant on the right. So this is a time when we would want to start by eliminating the smaller variable term. So I'm going to subtract x from both sides. 3x minus x is going to give us 2x. So on the left side we'll have 2x and we'll still have our minus 3. And we have greater than 7. Okay, now we want to isolate the variable term. So we want to eliminate the minus 3. So let's add 3 to both sides. And that will give us 2x on the left. And that's greater than 10. And finally, we want to isolate the variable. So we want to eliminate the coefficient of 2. So we want to divide both sides by 2. And that's going to give us x is greater than 10 divided by 2, which would be 5. Okay, now let's graph that solution on a number line. The numbers that are greater than 5 are to the right of 5. And we have the parentheses here because of the greater than sign. And the interval notation for this interval is parentheses 5 to infinity parentheses. Here is example 6. This one says 5 times k minus 3 minus 7k is greater than or equal to 4 times k minus 3 plus 9. Let's start by using the distributive property to eliminate these parentheses. So distributing the 5 here, we would get 5k minus 15 minus 7k is greater than or equal to, and now on the right side we'll distribute the 4. So 4 times k would be 4k, and 4 times minus 3 would be minus 12, and then we have our plus 9. Okay, now look again at the left side and see if there are any terms we can combine. So we have 5k minus 7k. Of course, that's going to add up to minus 2k. And then we have our minus 15 here, and that's greater than or equal to, let's look what we have on the right side. We have negative 12 and positive 9. Those two terms are going to add up to minus 3. So the right side will be 4k minus 3. And now we're ready to start the solving process. So notice we have variable and constant on the left, variable and constant on the right. So we want to eliminate the smaller variable term. So which is smaller, negative 2 or positive 4? Well, negative 2 is smaller, so let's eliminate the negative 2k term. So I'll add 2k to both sides. And on the left side, negative 2k plus 2k minus 15 will add up to negative 15. And that's greater than or equal to what we have on the right, which is 4k plus 2k minus 3. So that's 6k minus 3. Okay, now continuing to isolate this k term, let's eliminate the minus 3 by putting plus 3 on both sides. That will give us negative 15 plus 3 on the left, which is negative 12, and that's greater than 6k on the right. Okay, now I'm going to recopy that last result up here. And now we want to isolate the variable k, so we want to eliminate the coefficient of 6. So we'll divide both sides by 6. On the left side, negative 12 divided by 6 is going to be negative 2. And then we have greater than or equal to. On the right side, 6 divided by 6 is 1, of course, and that just leaves k. Now this is one of those times where our variable has come out on the right side. But remember, I told you never graph or try to give the interval notation when your variable is on the right, because this inequality symbol will mislead you. So we want to restate it so that the variable is on the left. If negative 2 is greater than or equal to k, that means k is less than or equal to negative 2. So now on the number line, where are the numbers that are less than negative 2? Well, those numbers are to the left of negative 2. And we have the or equal to bar, so we'll put a bracket there. and then the interval notation goes from left to right. So negative infinity to negative 2 bracket. Now here is an inequality that has fractions multiplied by a pair of parentheses, and we have that on each side of the inequality. Now I can imagine you're probably already dreading trying to distribute these fractions, but remember, we're not going to have to distribute fractions because what we can do is multiply both sides by something that will cancel out these denominators. So you just have to ask yourself, what is a number that 4 and 3 can both go into? In other words, what would be a common denominator here? Well, the common denominator for 4 and 3, of course, would be 12. So what we're going to do is multiply both sides of the inequality by 12. On the left side, 12 divided by 4 will be 3. That 3 times this 3 will give us 9. So now we'll just have 9 times x minus 6. Then we have our less than or equal to sign. On the right side, 12 divided by 3 is 4. That 4 times this 2 will give us 8. So the right side is going to be 8 times 5x plus 1. And so you see, just by multiplying both sides of the inequality by the same number, we were able to eliminate those coefficients, and this one will be much easier to solve than if we had to distribute the 3/4 and the 2/3. So now let's distribute the 9 here. So 9 times x would be 9x. 9 times minus 6 will be minus 54, and that's less than or equal to 8 times 5x, which is 40x, plus 8 times 1, which is 8. Okay, now again, we're in that situation where we have variables on both sides and constants on both sides. So let's eliminate the smaller variable term. So I'll say minus 9x on both sides. That gives us negative 54 is less than or equal to, on the right side, 40x minus 9x is 31x, and then we have our plus 8. So let me recopy that up at the top of the page here. And so now we're ready to isolate the variable term. So we'll need to eliminate this 8. So we'll say minus 8 on both sides. Negative 54 minus 8 is going to be negative 62, and that's less than or equal to 31x. So now we want to isolate the variable by dividing both sides by 31. On the left side, negative 62 divided by 31 is negative 2. And on the right side, 31 divided by 31, of course, cancels out and leaves us just x. So we have negative 2 is less than or equal to x. Notice that the variable is on the right side, so we want to restate this so the variable is on the left. So if negative 2 is less than or equal to x, that means x is greater than or equal to negative 2. So on the number line, the numbers that are greater than negative 2 are to the right, and we have the bracket there because of the or equal to bar. And now our interval notation will be from negative 2 to infinity, parentheses. Here is a similar inequality for you to practice with. I hope you'll pause the video for just a minute and try this one on your own, and then you can check your work with me. Okay, here we go. So first, we don't want to have to distribute the 1/2 and the 1/5. We would like to just eliminate these denominators. So we will try to figure out what is the common denominator for a 2 and a 5, and of course that denominator would be 10. So we're going to multiply both sides by 10. And when we do that, 10 divided by 2 gives us 5. That 5 times this 1 is still just 5. So the left side will be 5 times 3x minus 1 is greater than. On the right side, 10 divided by 5 is 2. That 2 times this 1 is just 2, and that's times x plus 4. Okay, now distribute the 5, and you'll get 15x minus 5. Distribute the 2, and you'll get 2x plus 8. And now we want to eliminate the smaller variable term, so we'll subtract 2x from both sides. 15x minus 2x is 13x, then we have minus 5, and that's greater than 8. And now we want to isolate the variable term, so we'll add 5 to both sides. So that gives us 13x is greater than 13. And now we want to isolate the variable, so we'll divide both sides by 13, and that will give us x is greater than 1. Okay, so now we are going to graph that solution. The numbers that are greater than 1 are to the right of 1, and we put parentheses because we don't have the or equal to bar. And then the interval notation goes from 1 to infinity.